Here. Let's take a look at this question on Fourier series using the trigonometric format. So here we have to find the trigonometric Fourier series of the waveform shown. So now this is the waveform. It's a sawtooth or triangular kind of waveform. In this waveform, this is the y coordinates and these are the x coordinates. So on the y coordinate we have A as the maximum amplitude of the triangular or the sawtooth waveform. And the x-axis we have minus 4 pi, minus 3 pi, minus 2 pi, minus pi, 0 pi, 2 pi, 3 pi, and 4 pi. So now if you take a look at this waveform, the most important parameter to first identify with respect to Fourier series is the period, because Fourier series is used for periodic waveforms or periodic signals. So now here, the period is the state at which the signal repeats itself. So now if you take a look from 0 to 2 pi, it's repeating itself. 2 pi to 4 pi is repeating itself. Minus 4 pi to minus 2 pi is repeating itself. Minus 2 pi to 0 is repeating itself. So now here, 0 to 2 pi, the period is 2 pi. 2 pi to 4 pi, the period is 2 pi. Minus 2 pi to minus 2 pi, the period is 2 pi. Minus 2 pi to 0, the period is what? 2 pi. So everywhere you go, the period is what? 2 pi. Now, the period must always be constant, as it is constant in this question. But it is good to take the period from a point which will make our calculations more easier for us. Now, having 0 in the middle will make it more easier for us. So I'll take it from minus pi to pi. That will also be 2 pi, because minus pi to 0 is 1 pi. 0 to pi is also 1 pi. That makes it what? 2 pi. Okay, so I'll take it from minus pi up to what? Pi. That makes it what? 2 pi. And which is the period of what? Of the wave. So t is equals to what? 2 pi. Alright? That is, I'm going to be considering this place and I'm going to be considering this place. Now, in this question, let me write down the period I have taken. Is equals to what? 2 pi. I also know that the frequency omega naught is what? 2 pi over period, which is t. So omega naught is equals to what? 2 pi over what? 2 pi, which is equals to what? 1. Alright, for the sake of space, let me divide my sheet into 2. Now, here, what I'm going to do is that I'm going to write the general formula for Fourier series with respect to trigonometric Fourier series. So f of t is equals to a naught plus summation up to infinity from what? 1. Okay, an cos omega naught t plus bn sine omega naught t. Please, is an cos n omega naught t and is bn sine n omega naught t. Alright, let me close it here. So now this is the equation. Okay. But I know that omega naught is equals to what? 1. So I can simplify my equation as a naught plus summation up to infinity from 1 into an cos n omega naught is 1. So now if I put 1 into this equation, I'll have what? Cos nt plus bn sine. If I put omega naught here, I'll have what? Nt sine nt. Now let me close my bracket. Now let me also identify the kind of function I have here, whether it is an even function or is an odd function. For even function, it is equals to f of t is equals to f of minus t. And for odd function, or odd signal and even signal, f of minus t is equals to minus f of what? T. So now here, if you look, minus 2 pi to 0, which is negative aspect of the waveform, is A. And then 0 to 2 pi, which is the positive aspect of the waveform, is also a. That means that the positive aspect is the same as the negative what? Aspect. That means that it's obeying what? Even function, or the signal is what? An even what? Function. It is not what? An odd function. Alright? Because odd function means that negative aspect of the curve, but I have nothing in the what? Negative aspect. That is, I have no negative f of what? T. Okay? What I have here, minus 2 pi to 0 corresponds to f of what? Minus t. Okay? And f of t here corresponds to 0 to what? 2 pi. So both the f of t, which is 0 to 2 pi, gives me a. And f of minus t, which is minus 2 pi to 0, also gives me a. That means that the f of t is the same as or equal to the f of minus t. That is what? An even function. It is not an odd word function, because it's not equal to something what? Like this. Alright? Okay. So now, if it is an even function, then the odd aspect will become what? 0. We know that cosine function is even and sine function is what? Odd. That means that the odd aspect of the signal is what? Sine function. So the sine aspect will become 0. That means that Bn is equals to what? 0. In that case, our function will now become as follows. Our Fourier series will now become as follows. A0 plus summation up to infinity equals to what? 1. And then you have an cos nt. Okay, so now here there is no sine aspect, because the sine aspect is what? 0, because it's an even function and it's not an odd function. Okay, so now let us determine our A0. So now A0 is equals to 1 over what? T into what? Negative infinity to what? Infinity what? F of t d what? dt. But we don't know f of t yet. So let's determine our f of t. We can know our f of t by the equation of these what? Lines. Because you can see that I took the function from minus pi to what? Pi. So let me write here, A0 is equals to 1 over, what is the period? The period, we got it to be what? 2 pi. Okay, the period is 2 pi. So 1 over what? 2 pi into, I'm starting from what? Minus pi to pi. So I'll write here what? Minus pi to what? Pi. F of what? T. F of t d what? T. Alright? Okay, knowing this, let's continue. Now, what we can do with respect to f of t is that we must find it by knowing the equation of the lines with which we formed our period. So those equations, the period is from what? Minus pi to pi. So minus pi is this line, okay, is this line, and then this line. Okay, so you know that this line is starting from what? Minus pi a to 0. Okay, so the points here are minus pi a to where? To 0 what? 0. Here, minus pi a. You write the x-axis first. The x is what? Minus pi. And the y-axis is what? A. Okay. And here it comes to what? 0, 0. So the slope m is going to be change in y over change in x. So y2 minus y1. So 0 minus what? So 0 minus what? A. Okay, 0 minus A. Y2 minus y1. And here, x2 minus x1. 0 minus what? Pi. Which is minus A over what? Pi. This makes sense because our line is from minus pi A to 0, 0, which is descending. So the slope has to be negative. Now, to write the equation is f of t minus, you take one of the points, 0, 0 is better than minus pi a, because 0, 0 will make our equation simpler. So 0, 0 here, so f of t minus the y component of the point you took. So the y component of 0, 0 is what? 0. So f of t minus the y component, which is 0, is equals to the slope minus a over what? Pi into what? T minus the x component, which is also 0. So now here you have what? F of t is what? Minus a over what? Pi what? T. That's our first equation. But you see that we have minus pi a 0 0 and 0 0 what? Pi a. This is also another line. This one line, this is another line. So we must find the equation for this line too. So here we will use points 0 0 2 point pi a. So the slope will be equals to 0 minus a minus 0 over pi minus 0, which is what? A over what? Pi. It makes sense because the line is ascending from 0 0 to what? Pi a. This point is what? Pi a, because it's what? Pi and then what? A. Pi a. So the line is ascending, so the slope will be positive. So we got a positive slope, which is correct. Now the equation is what? F of t. You can take either pi a or 0 0. It's better to take 0 0 because it makes our equation was simpler. So f of t minus the y component of this 0 0, which is 0, is equals to our slope, which is a over what? Pi into t minus the x component, which is also what? 0. So now our f of what? T is equals to what? A over what? Pi what? T. Now we have our two equations. Now we can just put them inside. Now this a naught, now a naught is now equals to 1 over 2 pi into, so now the first equation, which is minus a over pi t, is what? Is from what? Minus pi to what? 0. It's from minus pi to what? 0. This line, okay, is from minus pi to 0. So I'll put my limits as minus pi to what? 0. And the equation there is what? Minus a over what? Pi t, okay, plus the second aspect, which is 0 0 to what? Pi a. So which is from what? 0 to pi. Okay, you can see that this line is from what? 0 to pi. So I'll put my limits as 0 to what? Pi. Okay, so now here what I can do is that I'll write the equation here. A over pi into what? T. Okay, so now from here I can do some further simplification by bringing minus a pi out. In that case, I'll get minus a over 2 pi what? Squared into what? Minus pi what? 0. And t is the variable which has to be what? Integrated. So here I have to bring 1 over 2 pi here. Here I'll have a over what? A over 2 pi, okay, a over 2 pi squared into what? 0 to what? Pi, and then t, the what? T. So these are the terms I have to what? Differentiate. So now if I am doing this one, then I will have minus a over 2 pi squared into, if you integrate t, you get what? T squared over what? 2. Okay? And the limits are what? Minus pi and what? 0. Plus, okay, here you have to know this minus here is important. Okay, plus a over 2 pi squared. Here, if you integrate t, you get what? T squared over what? 2. And your limits are 0 to what? Pi. Okay, so let's turn over our sheet. Okay, let's divide it to have more space. Okay, so from what we have done so far, I'm going to have a naught is equals to minus a over 2 pi squared into, you put in the upper limit first. So I'll put in 0 first. If I put in I'll put in 0 first because 0 is my upper limit before minus what? Pi. If I put in 0, here will become what? T squared over 2. If I put in 0, it will become 0. Now I'll put in what? Minus what? Pi. So now minus pi what? Squared over what? 2. Okay. Alright, so this one, this part, plus what? A over plus this part also. Okay, plus this part also. So A over what? 2 pi squared into, I'll put in the upper limit squared, upper limit first. Okay, which is what? Pi squared into what? T squared over 2. So to what? Pi squared over what? Pi squared over 2. Please, I think from here, okay, when we come here, I think we can make our process a little bit simpler, okay, by taking the 2 here, all right? So if I take the 2 here, it will become what? 4. It will become 4, okay? So please, excuse me, let me rewrite it again, because I believe if we do that, our processes will be simpler, all right? So now, I just noted it, sorry, but we have to do it that way so that our process will be simpler. So now, here, this place is what? A naught. So minus what? Minus A over, I am bringing these 2 what? I am bringing these 2 out. So if I bring the 2 out, I'll have what? 4 pi squared into what? T squared. And the limits I have here are minus pi and 0. Okay? Plus A squared over what? So here, let me bring these 2 also out. Here like this. So I'll get what? 4 pi squared into what? T squared. The limits here are 0 to what? Pi. Now let me introduce my limits. Okay? So if I introduce my limits, I'll get minus A over 4 pi squared into 0 minus pi what? Squared. Okay? In that case, what I'll have is plus A over 4 pi what? Squared into, always the upper limit first. The upper limit is pi. Here, the upper limit first. The upper limit was 0, so I put in 0 first before the minus pi. Here, the upper limit is pi, so I put in pi first before I put in 0. So here, pi squared minus 0 squared. Okay. So now here, I'm going to have A naught is equals to minus A over 4 pi squared into minus pi what? Squared. So that would give me what? No, let me continue with, okay, let me continue. Plus this aspect also, which is A over 4 pi squared into what? Pi is what? Squared. So now if I add these 2, I'm going to get A naught is equals to, here, I'll have pi will cancel pi, but negative here will be positive. So I'll have A over what? 4. And here, pi will cancel pi. I'll have plus A over what? 4. So if you have A over 4 plus A over 4, okay, you are going to get you're going to get A over what? 2. Alright. So now our A naught here is going to be what? A over what? 2. Alright. Okay, very good. So now we know our what? A naught. So we will go on to our AN. Okay, we will go on to our AN. So we know that AN is equals to 2 over what? T summation minus infinity to what? Infinity. Okay. F of what? T cos n omega naught t. But omega naught here is what? We have identified it that omega naught is what? Omega naught is 1. Okay, omega naught is 1. So if you put 1 here, you have cos what? Nt. Okay. Alright, so the word t. So this is what we're going to have. Okay. All right. So now let's see something. Our f of what? T. Okay. So our f of t, actually, we can, let me introduce the limit before I even talk about it. So now here, 2 over what? T into what? Minus pi into what? Pi. Okay, minus pi into pi. F of what? T cos n what? T dt. Okay, so now here, what happens here is that if you take a look at this waveform, you see that minus pi to 0 is basically the same as what? 0 to what? Pi. So if I multiply 0 to pi by 2, I'll get what? If I multiply 0 to pi by 2, I'll get what? Minus pi to pi. Okay. See that it's what? Minus pi to pi. That makes it what? 2 pi. But if I take 0 to pi and I multiply by 2, it's the same thing as what? Minus pi to what? Pi. So instead of that, I will say that an is equals to 2, so I multiply it by 2. If I multiply it by 2, I'll get what? 4. I'll get here to be 4. Okay, over what? T. If I multiply here by 2, I'll change the limit from what? 0 to what? Pi. Because the distance of minus pi to 0 and 0 to pi is the same as 0 to pi multiplied by 2. Okay, so now here, if I am now using 0 to pi, if I'm now using 0 to pi, that means that I can use only one line or only one word equation, okay, which is what? A over pi into what? T. So now I can use A over pi to T, because if you check 0 to pi, what was our equation? 0 to pi, this point, our equation was what? A pi times what? A over pi into what? T. Our equation was this. So now here, I'll say that A over pi into what? T. That makes our equation simpler. Then I'll add a cos what? Nt. The what? T. Okay, so now I can say that an is equals to 4. Let me put the t value here, which is what? 2 pi. Let me bring my a out. If I bring my a out, I'll have here to be what? A. Let me bring this pi also out. Then it will be what? Pi squared. Then here will become what? Still 0 to what? Pi. And then I'll have my t will remain cos what? Nt the what? T. Alright, so this is what I'll have. Now, here you can simplify this one by using the UV formula of what? Integration, okay? Using the integration by parts. So with the UV formula here, UV is equals to U integral of V minus differentiation of U into another integral of what? V. Okay, this is the formula we have to use. So here, an is equals to 2a over what? Pi squared, by simplifying here. Okay, so now I am going to get t, and then I'll integrate this cos. If you integrate cos, what you're going to get is that you're going to get a sign. Okay, if you integrate cos, you are going to have sign. Okay, so now we will write that one and then proceed from that particular point. Okay, we will write that and then proceed from that particular point. So I'll have t sine nt over what? Over n. If you integrate cos nt, you get what? Sine nt over n. Okay, and you maintain this t. Now here, this part, the t, I'll differentiate t. If you differentiate t, you get 1. And this v cos nt, I will integrate it 2 times. If you integrate cos n nt, you get sin nt over n. Okay, and then if you integrate cos nt, you get what? Sin nt over n. Then you integrate sin nt over n. Then you get minus cos nt over what? You are integrating this one again. N what? Squared. Okay, so that is what we are going to have. Okay, so now we are supposed to get, but what you're going to see is that we will get minus cos nt over n squared. This minus here, there's also another minus here. So that means it will become what? Plus. Okay, it will become plus. So I'll have cos nt over what? N squared. Okay, so then I'll close it. I'll have 0 here, and then I'll have my pi here. Okay, so now from here, what I can do is that I can introduce my limits. Okay, I can introduce my limits. So now here, an is equals to 2a over pi squared into the upper limit first. So now here, I'll have pi sine n pi over n. Sine pi n pi over n is what? 0. Okay, then I'll put the same pi over into this one. Cos nt over what? N squared. So I'll have what? Cos n pi over what? N squared. Okay, so I'll have cos n pi over what? N squared. Then I'll put in 0 here. If 0 comes into, if this t becomes 0, the whole thing will become what? 0. Then I'll put what? 0 here. Cos n pi. Okay, cos 0 is what? Cos 0 is 1. Okay, cos 0 is 1. Alright, so now if cos 0 becomes 1 here, then what is going to happen is that I'll get 1 over n squared. But what you must also remember is that I am having cos, if I put in n pi, okay, over what? N squared. You see that this 0 is what? Subtracting. Okay, so it's minus, then here is 0. So here it's going to be what? Cos n pi is what? 0. So 1 over what? N squared. So here I'm going to get minus 1 over what? N squared. Okay. Why? Let me iterate what I just did so that you get it more. Okay, so this is my function. T sine nt over what? N plus cos nt over what? N squared. Okay, so the limit here are 0 and pi. So let me put in pi. Pi sine n pi. Sine pi is what? 0. Okay, so this place becomes what? 0. Cos n pi. Cos, if I put pi in place of the t, it will become what? Cos n pi. Okay, over what? N squared. So cos n pi over what? Cos n pi over n squared. So n pi over n squared. Then minus this 0 will go here. If 0 comes here, it's what? 0. So this place all becomes 0. So now this 0 will come here. Cos 0 n. Okay, cos 0 is what? 1. Okay, so minus 1 over what? N squared. Okay, so that is what is giving me this one. Alright. So now if I have this one, what I have to do again is that I just have to put in the general Fourier series formula because I think my formulas are completed. I've found all the necessary terms, which is f of t is equals to a naught plus summation infinity n from 1 an cos nt. Okay, we know that bn was 0, so we don't have to worry ourselves about bn again. All right, so inserting it into this one, we have f of t is equals to, we got a naught to be a over 2, so a over 2, and then an, let me bring my summation here, n is equals to n. We got an to be 2a over pi squared into cos n pi over n squared minus 1 over n squared. Okay, all this one times cos nt. All right, so now what I can do is that I can do some further simplification. Okay, I can do some further simplification. So now if I decide to put in my n, okay, n is starting from 1, so I can now decide to insert in the values of n so that I'll be able to expand this Fourier series which I have. This is the Fourier series, but I want to be able to expand the Fourier series. Okay, so now I'm going to put in some values of n from this point onwards. Okay, but we have to also remember that this Fourier series is for the interval minus pi less than what? T less than what? Pi. Okay, it is from this interval that we got this Fourier series. Okay, all right. So now going forward, we can say that let me put in n equals, let's say n equals 1. Okay, please, here is plus. We have to maintain it and then let it be there. So now here f of t is equals to, let's say we say n is equals to 1. Okay, n is equals to 1. If n is equals to 1, I'll have here a over what? 2 plus. All right, so plus here, I'll not bring the summation again because I am expanding the Fourier series. Okay, so 2a over what? Over pi. Okay, so here cos what? Cos nt. So now if I put here n to be 1, that means that I'll have what? Cos pi. Okay, I'll have cos pi. And then what is the value? What is the value for cos pi? Okay, I know that the value for cos pi is going to be minus 1. I'm going to show you that. But before I show you that, I can further simplify this one. So please let me do that and then let's move forward. I can bring this one here and say like this, okay? And then say 2a over pi squared, okay? I can bring 1 over n squared out. If I bring 1 over n squared out, I can say that cos what? N pi minus what? 1. All right, minus 1. Cos what? N what? T. Okay, I can say this. Okay, I can say this. Okay, so it's for the same interval. For what? Minus pi less than what? T less than what? Pi. Okay, so let's say now n is equals to what? 1. If n is equals to 1, here it will be a over what? 2. So the summation here. So square what? 1 over 1 squared is what? 1. Cos what? N pi. So if n is 1, that means that cos pi. What is the value for cos pi? If you want to know the value for cos pi, we can just draw the we can just draw the signal waveform for pi. Okay, we know that the signal waveform for pi is here is 0, and then it will come like this. Okay, cosine is always like this. All right, Okay, so now if here is what? 0, here is what? Pi on what? 2, because pi on 2 is cos 90, and cos 90 is what? 0, so pi on 2 is what? 0. Here is what? Pi. So now we have to know that this place is what? 1, and then this place is what? Minus 1. Okay, so that means that cos pi is what? Minus 1. Cos pi is minus 1. Okay, so now what happens is that if I put minus 1 here, that means that I'll have minus 1 minus 1. That will be what? Minus 2. Okay, that will be minus 2. So minus 2 will make, so minus 2. So now I can bring the minus 2 out, and then I can have this my cos nt attached to it. So now what I'll have is that if n is equals to 1, I'm going to have a over 2 plus, I will not bring the summation again because now I'm expanding my series. Okay, 2a over what? Over pi squared. So 1 over 1. 1 over 1 is what? 1. So this 1 over n squared will become what? 1 over 1, because 1 squared is 1. So I'll just leave it like that. And then I'm going to have here, remember that I got what? Cos pi, because if n is 1, then I'm going to have cos pi. But cos pi is what? Minus 1 from here. Okay, and minus 1 giving what? Minus 2. So now here I'm going to have minus 2 here, and then minus 2 over what? Over n squared. Okay, n squared, 1 squared is what? 1. Okay, and then here, if I put 1 here, I'm going to have what? I'm going to have cos what? Cos t. Okay, because it's what? 1. Okay. All right. So now I can further simplify this one as before I simplify that one further, let me go on to other values of n. So now let's say n is what? 2. If n is 2, that means that cos, if n is 2, that means that I'll have what? Cos 2 pi. Let's see what is the value for cos 2 pi. If here is pi, then here will be what? 2 pi. Okay, so what is 2 pi? The value for 2 pi is what? 1. Okay, the value for 2 pi is what? 1. If I put 1 here, that means that 1 minus 1 is what? 0. Okay, so the whole function will go to 0. So whenever I have any 2 pi, it will go to 0. So I have to forget about 2 pi. Now let me put in another value for n. So the next value for n is 3. If I put 3 here, here is what? 3 pi. If I put 3 pi here, is what? Minus what? 1. Because 3 pi, the value is what? Minus 1. Okay? So if I put minus 1 here, I'll have what? Minus 1 minus 1, minus 2. Okay? So minus 2, it will just be like this. So minus 2 out, and then I'll have this one which is over here. Okay? Which will be what? 1, which will be 1 over n squared. Okay, so now I'll have minus 2. Let me come again. If I put n equals 3 here, if I put n equals 3, okay, that means that I'll have cos 3 pi. And cos 3 pi, the value is what? Minus 1. If I put minus 1, I'll have minus 1 minus 1. That will be minus 2. Okay, just as I had for minus 1. Just as I had for 1 when I put 1 there. So now, what will happen is that it's going to be 1 over what? 1 over 3 squared. So 1 over what? 3 squared. And then it's still going to be this one. Okay, cos what? 3 what? T. Okay, so now let me put 4 here. If I put 4, cos 4 pi. Okay, so now this place, if here is 3 pi, here will be what? 4 pi. Cos 4 pi is what? 1. So if I put 1 here, 1 minus 1 is 0, so 4 pi will run to 0, so I don't have to mine it. If I put, here will be 5 pi. If I put 5 pi here, it's minus 1. So minus 1 minus 1, minus 2. Okay, so minus 2. Then it will be minus 2, and then the n squared, so 5 squared. So plus what? 1 over what? 5 squared. Okay, so this one will continue what? Like that. Okay, so now what can I say? I can say that f of what? T is equals to a plus what? A on 2 plus minus 4a, okay, over what? Pi squared. And then here, what am I going to have? Okay, so here it's just going to be cos what? T, which I have here for 1, plus 1 over what? 3 squared, because of the 1 over n. Okay, so now plus 1 over 3 square cos 1 over 3 square cos what? 3 what? T, plus 1 over what? 5 squared cos what? 5 what? T. So plus what? It goes on and on to infinity. So now you can see that an is equals to what? 0 for what? N equals what? 2, 4, 6, 8. Okay, that's all what? Even numbers. Because you see that whenever I put even number 2 and 4 inside, I was getting what? 0. Okay, so an is equal to 0 for that. Okay, then you can say that an is equals to what? An is equals to an is actually defined for this one. So these values I have here is what? An is equals to what I have here for all what? For n, an is equals to this series that I have here. For n equals to what? 1, 3, 5. Okay, and it continues what? On and on and on for all what? Odd numbers. Okay, the series is defined for what? Odd numbers, but for even numbers is 0, because you realize that whenever I put in the odd number 1, that is when I was realizing these values. When I put in 3, that was when I was realizing these values. And when I put in 5, that was when I was realizing these values. But when I put in 2 and 4 and 6 and 8, even numbers, I will be getting what? 0. Thank you very much for listening.